Now we can move on to finding the horizontal distance that the particle travels. Okay, so what's that? The horizontal distance is represented by that line, which means we want to be working with the displacement, the horizontal displacement. We also want to be working with the horizontal displacement here at t equals to 6 square root 2 seconds. Looking at our horizontal displacement equation, you can see that t is our only variable. Yeah, it's the only thing that varies what that is. The distance is just the time of flight. So literally all you do is just substitute it in. You have 30 square root 2 t multiplied by 6 square root 2, like that, and that just equals to 360 meters. So what we've worked out, that distance there is 360 meters. And how we've done that is we've looked at our horizontal displacement equation and we've seen that t is our only variable, and that whole motion occurs when t equals to 6 square root 2, which was our time of flight. So when y equals 0, when the particle came back down again. Yeah, can you see how everything's interlinked in these questions? You move from one to the other to the other. So now we move on to another one, which is finding the maximum height of the particle. So in this one, I want to be working out that height there. Remember, the maximum height occurs when your vertical velocity equals to 0. When you throw the ball up and it's just stopped at this point here. All right? So that means taking our vertical velocity, which we've worked out previously, make it equal to 0. In this one, what all you've done is 30 square root 2, move 10t over here, divided both sides by 10. That cancels, so you get 3 square root 2, which means that the maximum height occurs at the time of 3 square root 2 seconds. Now we worked out the time, all we need to do is substitute it in to the vertical displacement to work out what the actual height is. So that's exactly what we do here. The maximum height occurs at this time. So looking at this equation, wherever there's t, substituting in that, -5 times 3 square root 2 squared, just work that out in your calculator, and that should be -90, and 30 square root 2 times 3 square root 2 should give you 180, and add that together, and that gives you 90 meters. So that means we've just worked out that height there is 90 meters. So your maximum height for this particle is 90 meters for this case. Now we're going to move on the trajectory. So remember, that was the equation of the path, right? And the trajectory equation of the path describes that line. And do you remember what I said about this in relation to these ones? How these, in terms of parametrics, the t were the parameters, whereas when we talk about the trajectory, we actually want to only in terms of x and y. If we only want it in terms of x and y, that means we can only obtain the trajectory by eliminating t. First of all, to eliminate t, using this equation, I will eliminate t by making t the subject of that. So using this and that equation. So eliminating t there, all you've done is divided 30 square root 2 over. So you get t equals to x on 30 square root 2. And wherever there is t here, so with t squared and t, I'm going to put in x on 30 square root 2 instead of t. So substituting that in, all right, and then just some cancelling. That cancels with that. You can just put -5 divided by 30 square root 2 squared into your calculator, and that should give you 1 on 360. So x squared on -360 plus x is the equation of the trajectory, yeah? Because that's only x left over there. So equation trajectory, remember, in terms of x and y, which means you want to eliminate t. And what you're working with is both your horizontal and your vertical displacement equations, but you want to get rid of t. And how you do that, make t the subject there, and wherever there's t in your vertical or y, substitute it in, and then you have in terms of x. and y. Okay, here we're going to be working with our trajectory equation. Question 1H wants us to find the height of the particle when the horizontal distance is 10 meters. So that means 10 meters, maybe somewhere around here. I want to find the height there. And what equation am I going to use? Well, it makes sense to use that trajectory equation, doesn't it? Because that's the only one which is in terms of x and y, which is what we have here. Substituting what the horizontal displacement is, x equals to 10, into the trajectory equation, literally just substituting, you get y equals to negative 10 squared on 360 plus 10. So our equation there, we're just putting in x equals to 10. And putting that into your calculator, you get approximately 9.72 meters, which means that this here is 9.72 meters. So when we've gone horizontally 10 meters, we've actually only gone vertically 9.72. So whenever you see the question talking about giving you the horizontal, so that's going to be your x, and then wanting you to find out the height, which is your y, you think, what's the equation I have that only has x and y? Well, that's your trajectory equation. Okay, so last question now. I want to find the horizontal distance when the height of the particle is 50 meters. Now, this is an interesting one because I want you to consider this. If the height is 50 meters, so let's say here, when it's 50, can you see how there's going to be two values? Yeah, because when you throw an object up and down, there's going to be 2 points at which the object is at the height of 50 meters, which means you should definitely get 2 answers in this case. Now, working with the trajectory equation, we're going to substitute y equals to 50 into this equation. So you have 50 equals to negative x squared on 360 plus x. And you can see that kind of looks like a quadratic equation, right? So multiply everything by 360 and then getting rid of the negative, you get x squared minus 360x because that's multiplied by 360. 50 multiplied by 360 is 18,000 here. And we've just moved that over to get this quadratic. And now we think to ourselves, what's two numbers that add together to 360, negative 360 actually, but multiply to give you 18,000? And those values are actually negative 60 and negative 300. So you can see minus 60 minus another 300 does give you negative 360. Negative 3 times negative 6 gives you that 18, and you get 3 zeros, so that gives you the 18,000. So we factorize it to x minus 60, x minus 300, which means that when y equals to 50, x can equal to both 60 meters there, as well as 300 meters over there. So that's a difference between when you're working out the horizontal distance compared to the vertical distance. So for one horizontal distance, you can only have one vertical distance. But for one vertical distance, it makes sense why there's going to be two horizontal distances. All right. So just remember, with working out the horizontal distance here, make sure you've got two answers at the end.